I'll start recording now. So this is our last lecture this semester. We'll be moving on to some more things next semester about exporting out of Rhino. What I want to do is show you a few sort of slightly disparate things today, but to kind of mop up a lot of the stuff that we've had, that we have been raised as we've gone through the lecture course so far, that either we need to go back and just make sure that we've covered, or that I think would be interesting for you guys to kind of push things ahead a little bit and see what's potentially possible for starting to investigate as part of your design process next semester and finishing off this semester as well. Now, the first thing, and probably one of the most important things, is that the digital realm is something where we can simulate and make decisions before it costs lots of money in the real world. I'm going to give you a lecture next semester on BIM, which is called Building Information Modeling. This is what I spend a lot of my day job worrying about and thinking about, is how we build models of buildings in the digital realm so that we can make mistakes first where it doesn't cost us anything. And then when people actually build things in the real world, they've kind of learned a lot from those mistakes. But there's a really, really important way in which we can, here we go, we can start to imagine what it's like for our digital designs to be in the real world, and then see how they would perform in some really, really important climate ways. And one of the most important ones is a lecture that is usually part of the technology module, but was delayed this year, partly because of some licensing issues. But we've now got that sorted. And what you will now have is a message that's arrived through the Moodle announcement forum. It's under announcements in Moodle. And we now have a license key for something called Climate Studio. And what Climate Studio allows you to do, I'll just pull up the website, Climate Studio, is it allows you to simulate things like solar analysis, daylighting, thermal analysis, how your building might behave if you had to actually keep it warm in the winter and actually keep it cool in the summer. But not only how it's going to behave in a kind of qualitative sense, but actual data around that. This is an incredibly powerful tool, and I want to give you just a little bit of an intro to it today. I'm going to spend about 40 minutes giving you a small intro to some of the daylighting analysis tools. However, the fact is that you can go to solema.com, and I've put a link in the announcements that I made. You can download it from this website, solema.com, and then that's the download link, but you can go to any part of that website. Here is the license key that you're going to need if you want to install it on your computer. But this tool has a whole load of stuff that you can do, and then there's a whole series of video tutorials at the bottom. So if you're interested in a particular way of working, especially when it comes to sustainability or environmental metrics, environmental modeling and simulation, you can basically pick anything that Climate Studio can do, and you'll find a tutorial on how to do it on this website, and then you can follow it on your own. And that might be really, really helpful for you when you're demonstrating that your design is going to actually meet some kind of sustainability criteria, rather than just go on vibes or feelings. These are really, really helpful. Basically, everything you need to know is here, and all of the walkthroughs are also on YouTube as well. So there's tons and tons of stuff to get involved in. But I'm just going to give you a quick intro to how it works and sort of the way in which you approach this idea of You've got a digital model, well, what can you do with it? It's kind of a continuation of what we were talking about last week. What use is it having a model until you actually get something out of it, like drawings or a physical thing or printouts or sketches or ideas or renders or whatever. And this is about how we basically close the loop. The very, very beginning, I don't know if you remember way back, very beginning lecture, I showed you that you can get data on the weather off the internet. It's called EPW files, energy plus weather. You could basically find an airport near you and it would have a weather station. You could download all the data from that weather station. This is going to use exactly the same data. So we're kind of closing the loop on all the data stuff. The data was helpful back then. We can actually use it now. So let's just build something super simple, which we're not going to spend a long time on. But I mean, effectively, I'm going to do this completely by eye. Maybe it's a simple box, and then switch to my ghosted mode. I'm going to shell, and the thickness is going to be 300. Remove that and that. And I've got some walls, and now I can cut some. Set C plane to this face. Here we go. And cut a nice big window in here. Woo, it's pretty massive. There it goes like that. I just drag that out and we'll go make hole in here. Boom, there we go. So we've got a big opening in our thing. Maybe we could have a smaller window. We rotate that around. Bring it over here. Maybe there's a couple of windows in this side. Here we go. Make hole. And because I'm organized, I'm going to make this layer here into a glass layer. Make a glass layer, color it cyan. For some reason, I always end up doing it cyan. And importantly, I come back down and set my C-plane to the world top. And I'm literally doing this by eye. You would spend a lot more time getting this right. But hopefully you're following what I'm doing here. Basically filling in these windows with some bobs. And no, thank you. I want this guy here. Maybe we'll rotate him. Make a wider window. You know what? Let's put this on the north side rather than the east. Okay, super simple. And then also what I want to do is I want to make a nice simple floor plate that's just going to cover the whole thing. So then the last thing is I'm going to come over here and do a surface that covers the floor. And the important thing about this is this surface, you'll see, if I press DIR, you'll see this surface is kind of pointing upwards. It doesn't absolutely have to be, but it's helpful. This is going to be an analysis surface. So I've kind of done my model, but basically I've now covered the floor in a particular surface. And that analysis is because basically I only really care about what's going on inside my building. I don't particularly care about what's going on outside my building. The inside is what I can control through openings and different materials and that kind of thing. Finally, I need a roof. So I'm going to come over here, put roof on my building. And let's just expand this out a tiny bit so it's got a little bit of an overhang. I mean, super, super boring building, but your building would be more interesting, I'm sure. But certainly it's enclosed and it's got a couple of materials. I've got a glass material and I've got sort of everything else material. So what I can do is I can come in here to my Climate Studio plugin. In order to download it, you download an MSI, install it. It only works on Windows. So for those of you with Macs, very sorry, you're going to have to buddy up with someone else. Install the MSI. You have to do it with Rhino not running. And then when you fire up Rhino, basically you'll have a new toolbar. And it looks like this. I've docked mine to the top here, so I've got access to it whenever I need. But I can do that just like that. And there's like a handful of buttons here. And the first button looks like a cloud with a little sun beside it. And that's the site analysis. And basically, with Climate Studio, when you're doing this kind of analysis, you run through from start to finish. So you go from the left button, and the first button is site analysis, and a window will pop up that you can then put somewhere else. And for ease, what I'm going to do is I'm going to come over here and make my layers panel a little bit smaller, just so I've got a bit more space to work. And then I'm going to take this panel, I'm going to dock it to that side. So now I've got two panels on that side of my screen, and I can make the Climate Studio one a little bit bigger. So I'm basically going to work in this panel and then have my model over here. But you can set up your workstation however you like. If you've got two screens, you could put Climate Studio on one screen and the model on the other. The first time you run any analysis in Climate Studio, it will pop up with a window saying, enter your license key. And the license key is on your Moodle announcement page. Which is here. If you just go to forum announcements, Climate Studio license key, you'll be able to read it from there. Just copy and paste that first line. It's this one that ends 112. So there's your license key. So the way this works is that the first thing on that list is site analysis. And if I use this drop down, you'll see the same icons here that you see in this thing. So to be honest, once you've opened the first one, you can kind of ignore these buttons. And basically, we're just going to run down the list. So we're going to do site analysis. And we have to, first of all, decide where in the world we are. And where in the world we are makes a huge difference to the climate and environmental performance of your buildings. Why might that be? Well, you can kind of put it together. Right now, it's really cold outside. So the most important thing that we might want to be aware of is how much energy it uses to heat this building, or the sun comes in at a certain angle, and we might want to be designing a library where people are working, and so we want to be quite careful about things like glare. So there's too much light in the room, people's eyes tend to really struggle to focus on things. And so we need to know where we are in the world, and we're going to say I can basically click on this little folder icon and browse a whole load of files. And these files, if you remember back all the way to the very, very start of our lecture series, these files are the same files that I showed you that you can download the climate data from these stations. And most of the stations are airports because they've got weather stations built in. These are literally the same files. You're just downloading the same one. So yeah, we can come in here and search for London Heathrow International Airport. And I can click on that, press OK, and it will download that file. And now it tells you that it knows that we're in London, and it's got a longitude and latitude, and it says temperate, no dry season, warm summer. So there's a whole load of information about the climate just on this first page, which is the Köppen climate zone, basically sort of characterizing the UK climate as being, we don't have a dry season or a wet season. It's not like we have a monsoon and then a non-monsoon. The summers are warm and it's temperate. It's not like Arctic or anything like that. Average annual temperature is 11 degrees C, and the average annual total solar radiation is 1,244 kilowatts hours per meter squared. Useful if you want to put solar panels on a building. Coldest month is February. That's coming up. Great. Everyone looking forward to that. Anyway, great, right? Well, we can show a little compass on our model, and now we know where north is all the time, which is kind of helpful. That can be useful. Just always have that compass in the display. It's a little bit big, so maybe I'll come down here and make it a little bit smaller. So now we know which way north is. And I can also offset that north any direction I like. I'm going to come into this tab here that has the little sun with the sun and a cloud. And then this is where I can start to do a whole load of things with these tabs that suddenly appear underneath it. The first thing I can do is I can turn on a 3D sun path. And now I have a three-dimensional representation of which angle the sun is coming in to my building at every hour of every day of every year. And we can sort of basically understand this as here we set the date. The date is basically going to change the height of the sun in the sky. Here we set the time, which obviously goes from morning through to evening, dusk till dawn. And it's actually possible to change various things here, but that's with the display down here. But Angular is probably the easiest way. And it gives you a two-dimensional sun path, which is quite useful. You can print it out to PDF or a PNG, and you can put it over a map on in a plan. Or you can use the 3D. And the 3D will obviously then show you if you had a question like, at what angle will the sun be at a particular time on a particular day at a particular point in the year, you can now find out exactly which angle the sun is going to be coming in and hitting your building at. So on May 17th at around 2:30 p.m., the sun will be there in the sky. That's exactly where the sun is going to be, and it's going to be hitting it at that angle. Everyone happy with that so far as an idea? You can also turn on shadows, which is kind of fun, because if I just turn off the glass layer and make those windows just openings, then we start to see how the shadows internally are going to be affected by different points of the time of day and the year. So now I can actually see the shadows as they move through my building. This is kind of what I've already talked to you about a little bit in the technology lecture. You can effectively do quite an easy little solar analysis here. But we can do more. As well as a sun path, let's just turn the shadows off because I don't think they display particularly nicely. I can turn my 3D sun path off, and I can show a windrose. Maybe I just bring that internal radius down a little bit. So this windrose, hide that, there we go, shows me which direction the wind comes from at different points in the year. How much wind is coming from the west, how much wind is coming from the southwest. You get the idea. And you can also break this up and say, I'm only concerned about the wind that comes during May and June, or whatever it might be. And as you change through the year, you'll see different variations in where the wind comes from and how strong it is. Happy with that? We can do other things as well. We've got a chart here which you can print out to PDF or PNG. Let's just get a PDF of that. Press export. And now there's your temperature averages. This is just a temperature chart. And basically what it's saying is January, February, and I'll just make this bigger if I can. Can I make it bigger? Yes, I can. There we go. Here's your months, January, February, March, April, May, June, July. And then each one of these is an average day in January, an average day in February, an average day in March. And what you can see is that each of these columns goes from midnight to midnight on an average day. And you can see that at midnight, it's super, super cold. And then the temperature rises as the sun comes up. And then it's nice and warm at midday. Maybe the hottest part of the day is kind of like 1, 2 o'clock. And then as the sun sets, it gets colder again. And then we go back to it being nighttime. This temperature here is the blue line is your average daily temperature. And then these red lines are your radiations. This is basically solar radiation. This is how much light, how much energy is coming from the sun to warm up your space at different points in the day, which is why it goes to 0. Because at night, there's no sun. Happy with that? Cool data, all within Rhino. Psychrometric charts. This is saying, I'll pull this up so you can see a little bit better. Some data about our particular site is that it is dry and not very humid, not particularly humid. So this dry bulb temperature, degrees C, this is drier than, say, a really tropical area would be hot and humid, and this is cold and not so humid. So if I was to take this same chart and change to somewhere hot and humid, what's the hottest and most humid place you've been? Anyone been traveling anywhere with a jungle? Colombia. Amazing. Okay, so what we could do is come over here and we could say, right, I'm going to find Colombia. What's the airport in Colombia that you flew to? What? How do you spell that? Yeah, there we go. This is the one. Okay, here's Colombia's information, and suddenly it's all changed. So now I've got wind coming from a completely different direction. But not only that, I'm going to pull up this psychrometric chart. Do you see everything's hotter and more humid? So basically, we're on this curve between generally what happens is the hotter the air is, the more moisture can hang around in the air, which is why there's this curve to it. This is really, really useful, especially if you're designing a building that uses something like active ventilation or stack effect ventilation or something like that, where evaporative cooling is an important part of it. And then finally, I'm just going to come back here and change back to Heathrow. Doop, boop. Here we go. Here we have a cool graph, which just looks like a whole random splodge of colors. But what this is not just saying it's cold in the winter and it's hot in the summer. It's saying if you were a human outdoors with no shelter, what type of temperature stress would you be under? And the answer is you can have extreme cold stress, strong cold stress, no thermal stress, which is green, which basically means you could just be outside in your jumper or maybe a t-shirt, and you don't really need anything else to feel happy. Or you can have heat stress, extreme heat stress. So this is for London. You'll see there's a lot of green there. There's a lot of times in London or in the UK where it's possible to be out and about, and if you found yourself with no shelter, you're not going to massively complain. Even at some points, this is hours in each day, this is at midnight, so there's this day here where actually quite a bit of the night, these days here, quite a lot of that night is just perfectly nice. So if you were homeless on the street, yeah, you could sleep through the night. However, come over here And this area here, you would experience quite strong cold stress if you were outdoors in February, pretty much at any point in the day. If you didn't have shelter in January and February, you are not having a good time. And this is really helpful because this helps us understand, like, well, why is the way we design architecture so important? Well, it's because at its basic level, this is sheltering us from stress that our bodies cannot cope with. Again, if I come change our location here to somewhere where you would experience quite significant heat stress, a hot country. I wonder what the hottest country you've been to might be. Shall we think of somewhere near the Sahara? Is there? No. I'm just going to pick something that I can see. Why don't we Google hottest country? Burkina Faso. Burkina Faso capital. Anyone know the capital of Burkina Faso? Oh, it's don't even know how to pronounce that. Oh, Ouagadougou. Assume they do not have data for Ouagadougou. Mali airports. Oh man, come on. Gambia airport. Banjul. Yeah, I know. Oh, well, this is annoying, isn't it? Come on, let's just find a, all right, I'm going to come back to this. Let's just do Abu Dhabi because I know Abu Dhabi has a big international airport. There we go. All right. Now, let's come and have a look at that same graph for Abu Dhabi. The majority of the time that you are outside, you will experience somewhere between strong and extreme heat stress. So a very different set of climate needs, depending on where you are in the world. Okay, you get the idea. I'm going to come back here and come back to the UK because it's cold today, and we'll think more about other things. So we've got the data for what the climate is like around my silly little building that I built in 2 seconds. So what I'm going to do is come over here and we'll look at, I want to look at daylight availability. Daylight availability is fairly simple. What it does is it says there are going to be times when the sun comes into your building. There are going to be times when the sun is not coming into your building or it's in shadow. And what we need to do is, first of all, work out the materials that are the real world materials that apply to things in my model. So my default layer is currently what I have all of this sort of solid stuff on. And all I need to do is click on default and then set a material. So I'm just going to set this blank wall material. It's just literally it doesn't let any light through. It's just white wall. However, I do need to set a material for my glass layer. And that's because the glass is going to let some light through. However, it's not going to let all the light through. So what I need to do is come over here to opaque material and instead say this is exterior glass. I'm actually going to say exterior glass translucent insulating. So this is like double glazed or triple glazed glass. If you're struggling with the sun, I think there is a button on the wall to turn some shades down. Feel free to go and investigate if you want to. Right. Okay, so I can find here some translucent glass material. I'm just going to choose one and select that. And so now I've set a glass material on my glass, and I've got a general thing here. And then the last thing I need to do is I need to add an analysis area, which is this surface that I put in right at the beginning. I'm going to go to add areas, and I click this little area with a plus, and then I'm going to press OK. There we go. And now this, if I just, no, I don't think I want to hide that. There we go. I'm going to switch my view to wireframe. So now I can see through all my walls, which is quite helpful. And there's a little button. Now I've set my area, my analysis area, and I've set the materials in my model. I can run a simulation, which is this green button. I can say start simulation. And if I click the button, first time you ever do that, it'll ask you for your license key. You just type it in. And this is now, whoop, it's thinking. There we go. And it's finished. Run complete. And so what's going on here is that now I can see these areas around my windows have now sort of lit up a different color. What's interesting is that this is a very, very low daylight factor. This is a daylight factor of 0.4%, which probably suggests that the glass that I have put on here is it's translucent. It's translucent. That's probably why. Let's go exterior glass Atlantica clear. There we go. Select, and then we'll run the same simulation again. No. There we go. Right. So the glass that I put on before was basically not letting much light through at all. It was translucent. It was kind of like blocking quite a lot of light. This glass that I've just put on is really, really clear. And you'll see now that this is showing us like a heat map of areas of our building that are going to get daylight. And a daylight factor is a super, super simple metric. I think, did we talk about daylight factor a little bit in our tech lecture? The daylight factor is a super simple metric. It's basically, if you're outdoors and there's nothing stopping the daylight from hitting you, you are in an arena which is 100% daylight factor. If you are in a black box which doesn't let any light through at all, you have a 0% daylight factor. And then most buildings are somewhere in between. We're blocking out quite a lot of daylight right now. If you took away all the walls, all the roof, all of the everything, and we just had this projector screen in the outside area there, you wouldn't be able to see it very well at all because the level of daylight would be really, really high. If you go to a cinema, the daylight factor is really, really low because they don't want any daylight in a cinema because you need to be able to see the screen. In fact, the daylight factor in a cinema is 0. You're basically in a black box. Or a theatre, for example. Don't let any daylight in. Most buildings, you want a daylight factor. And in fact, there's some really useful things here. I think it's the CIBSE daylight factor. There we go. There's a CIBSE paper which tells you daylighting and compliance. There you go. And there's a whole paper about different activities that you might need to do and the daylight factor that works for that. So if you are, for example, like you work in very, very small mechanical things, like you're a watchmaker and you need to make like a tiny cog, you need a very, very high level of light in order to do that kind of work. On the other hand, if you are a worker who spends a lot of time looking at screens, you might need quite a low daylight factor, so there's less glare. Anyway, you can look that up, and you can basically now design your room and your building based on a daylight factor that's not too high, not too low. So I could change my mind now about this huge window on the south, where actually the daylight factor here is a little bit too high for my liking, and come in here, and you know what we could do? We could take this, edge, and we could bring it out a little bit, and we could rerun the simulation with shading. And that's running now. And that's finished. And now you see the daylight factor over here, that's become much more even and a little bit nicer. And what I can do is I can compare the two designs and choose which one I like. So now I'm using the simulation to inform my design. Do you see what I'm going for there? Yeah, cool. And this on its own makes an amazing portfolio page. That my roof was here, it was in here, and this is the result I got. I changed the roof, and then I got a more even coverage of daylight factor across my building. Similarly, we can do things like glare. So glare analysis, this is basically saying, well, let's just bring this in here. There we go. I'm going to run the same analysis. There we go. And this is glare. This takes a little while because what it does is for every point on my analysis surface, I'm going to, what's going on behind the scenes is that if you imagine a little tiny camera pointing in all eight directions, and then it's going to ask the question, if I was standing in this spot and I was looking in this direction, what would the amount of direct sunlight hitting my eyes be? And if the answer is, it's all just a little bit too much, then it will classify that glare level as negative or intolerable or not very nice. However, on the other hand, if you're standing in a particular place and looking in a particular direction and you don't have huge amounts of direct light hitting your eyes, then maybe the glare is absolutely fine. What it's saying to me is it's put these little pizzas all over my thing here, which is to identify basically that in this location, if you're pointing in this way or this way, you're probably fine. But if you're pointing towards the window, then what you're looking at is basically over 12% of your time, in fact 15.3% of the time in the year, the glare in that place is intolerable. It's like trying to work in a greenhouse. Your eyes will just not thank you. And this is basically kind of giving us a little pointer that maybe this is not a very nice place to be working. If you were designing a little studio for some architects to be in, you basically can't put desks anywhere here because half the year they're just going to be complaining that they can't see their screens. So again, let's do some changes to our design. We can drag this shading out a little bit more. We could also maybe just, here we go. Let's just reduce the size of that opening so it's not quite so massive. There we go. And I'll rerun that same simulation. So we've done a couple of things there. We've got shading now, and we've reduced the size of that opening. And hopefully our pizzas are going to start to look a little bit less red. There we go. Looks like we've solved that problem. And there's one tiny bit where right next to the window, maybe it's not quite so nice to work, but we haven't got any of that red anymore. Do you see what I'm doing? I'm kind of trying to use the simulation to imagine what it's really going to be like, rather than just look at the design in a digital isolation and just go, oh, well, it looks nice on my screen, let's build it. Okay, cool. We could carry on. And then in the last 5 minutes, we'll try very hard to do a thermal analysis. And this is one that I probably would suggest that you go away, if you're interested in a thermal analysis, go away and do the tutorial that you find on the Climate Studio website. A thermal analysis is a little bit different. And what the thermal analysis is going to do is it asks us for some volumes that aren't actually like the same as the way that we've built our building over here. The way we've built our building over here is with like actual thick walls, and every time we put in a glass thing, we've got like, you know, a proper chunky everything. A thermal analysis is much simpler than that. It just uses volumes to represent areas. So I'm going to come into my ghosted mode, and I'm going to say, look, let's put an opening here. And that is going to be on that layer. And that surface, let's just scale that down a little bit like that. Again, we can do the same thing over here. Boop, boop. Project layer. I'm going to keep this super, super simple. And then finally, I'm going to put a surface on the ground because we need to say that this building is sitting on the ground. So here we are. We need objects, and these objects are now going to be firstly a zone. We're going to create a zone by default ground boundary. Yeah, there we go. Where are we? Select closed volumes as zone geometry. So this is the difference, that before we modeled the walls, now we have to select a closed volume, which is just a box. That's all it is. So I'm going to select this closed volume as my zone geometry and then press enter when done. And then it asks me a whole lot of questions about this. I'm going to say this is my studio, whatever it is. The building type is going to be office, dining, healthcare, whatever it might be. Let's say office. Now, the reason for choosing the space use is because different spaces get used at different times of the day. An office gets used between 9 and 5, but during the night, there's no one there. So you don't have to heat an office at night. Whereas a residential building, you might have to heat it more in the evening than during the day because lots of people might be out at work in an office. You know, maybe you work from home, maybe you have to heat your building the whole time because you work from home and you also sleep there. So different space uses are going to have different impacts on the energy use that you need in order to keep this going. I'm going to select all of the defaults there. And then here's my studio. And this has actually added some windows to my facades. It's actually added this thing here. And what I'm going to do is get rid of those because I don't actually need them there. Let's just put them in the bin. Come on. Yeah, there we go. That's interesting. There we go. the window to wall ratio is, I'm going to set to 0. And then it's going to get rid of all of my windows. There we go. That's all that's happening. Now I can do is add a window, and I'm going to set the default glazing to be double glazed. And that will do for now. And where is it? Add edit window. There we go. There it is. So what I've done is I've got a surface that's literally sitting on top of that box. I'm going to select that one as well, add that window, press OK. There we go. And now the model knows that there's a break in the box to let a window in there, and there's a break in the box to let the window in there. And now I think I've got everything that I need in order to run this simulation. So I'm going to click Start, press Yes. And then it's going to do a whole load of calculations. And that calculation is based on a number of factors. So one of the biggest factors is it knows where we are in the world because we've loaded the climate data. It knows how hot, how cold it is outside. It knows when the sun is going to shine through that window and when it isn't. And it knows when that solar gain is going to give you heating effects or not. It knows when people are in the building and how much energy it's going to use. It knows what temperature that you want that building to be kept at as a constant office temperature. And it's worked out over the year, here is the energy usage that you need in order to run your building. So it's basically predicting what your bills are going to be, your energy bills are going to be. And what you'll see is that the vast majority of the energy use in this building, as it currently stands, is spent in heating it. The main reason that we're spending so much money heating this building is because, and just we'll keep that in our minds, this window, I'm just going to come in and edit this window. Do you remember I tried to select a double glazed unit? It didn't seem to work. I will now. The default glazing unit is simply a single glazed piece of glass. Have you ever been in a building that has just single piece of glass in windows in winter? It is cold, right? And if you want it to be warm, if you want to get that building up to like 21 degrees or whatever you need an office to be in, you have to pump in a ton of heat. So what I'm going to do is I'm going to turn that into double glazing, press OK, and then I'm going to take this window and turn this into double glazing too. There we go. And then I'm going to rerun the simulation. So the previous one was single glazed. This one is going to be double glazed. It's going to take a little while to have a think. There we go. And let's compare the two. So single glazing, we're using a lot more heat energy to keep us at the right temperature. All I've done is change to double glazed windows, and all of my heat values have just gone down. Does that make sense? Hopefully that sort of makes sense with what your experience of different types of windows is, but now you can actually prove it. Now, similarly, we can do other things as well, which is what if we change the orientation of our building? We take that whole thing and we rotate it 180 degrees. So now my windows are no longer on the south and west side. They're now on the north and the east side. I'm going to rerun the same simulation. So this previous one was with south windows, and this is going to be with north windows. And let's see if it makes any difference at all. So with south windows, here's my heat usage. With north windows, here's my heat usage. The only thing I've changed, same building, same double glazed windows, I've just put the south window on the north instead. And my heating bills have gone up. Why has that happened? Any idea? Have you been in winter? You sit next to a window with the sun coming in. Feels nice and warm, doesn't it? Lovely, like cozy. The sun's coming in. What you're getting then in the winter is solar gain. You're getting heat effect of the sun coming in and warming the building. And so what happens when you move a south-facing window onto the north face is you lose out on that solar gain, and all of my heating bills in the winter have gone up. Now, on the other hand, if you were thinking about the fact that it takes quite a lot of energy to keep your building cool in the summer, like, for example, we were in Abu Dhabi, the opposite would be true. By rotating my building, I might have saved energy. Anyway, here's the actual data of like what it's really going to be like inside my building, the thermal modeling. And you can go into quite a lot of detail with this. I just want to give you an overview that this tool is now available to you, and it's worth playing around with, seeing what you can generate and seeing what you can simulate about the building before you've even designed it. Ideally, you even get a sense of like, is this going to be the kind of building that I want to be in? Is it going to be too cold? Is it going to be too hot? Is it going to be too glary, too bright, too dark? Often dark buildings pretty depressing to be in. Have we let in enough daylight to actually let people feel human and alive? I'll pause there. Any questions on what I've just shown you, or anything that you think, oh, I'd love to be able to know more about that? Yeah. No, you install it, and it installs as a plugin for Rhino. So the question was for the recording: do you have to do anything to link them together? No, it comes as a plugin for Rhino. You have to have Rhino installed first, and then it finds Rhino and goes, oh, I'll just add a little extra toolbar to it. Yeah. Sorry, I can't hear you. This one? Yeah. Oh, where do you find it? If you've installed Climate Studio and it has successfully installed, but it hasn't given you the toolbar, what you do is you go to Window Toolbars, and then what you should have is two sets of things in the drop down. One says Default and one says Climate Studio. And the Climate Studio one has a little thing that you can tick on and off. Does that make sense? Window, toolbars, and then basically you find Climate Studio in the list. And if you don't find Climate Studio in the list, then it may not have installed correctly. Okay. Let's have a break. We'll come back and I'll show you some cool things with parametrics.